Sorry, I'm just going to make the data myself, and then we're going to get going. So, that was a strange conversation. I can tell this is going to be an interesting day already. So what we've done so far is we ran a logistic regression. The idea behind the logistic regression is that we want to predict this yes-no variable. So in our case, what we're trying to do is we're trying to predict whether or not we're trying to predict this yes-no variable. So in this case, what we're trying to do is we're trying to predict if a person purchases, in this case, a new car in a year. Okay? So what we're trying to do is we're trying to predict this yes-no question. Does a person purchase a new car in a year? And we have some information, some data that we think might influence whether or not a person purchases a new car. And so in the data set, it should be appearing in just a second. What we have is we have the income for a household. So in this case, we have their income in thousands of dollars. We have how old their oldest vehicle is. We have whether or not they just recently had a child or found out they were pregnant during the year. And then we finally have our dummy variable of did they purchase a new car or not, where 0 means they did not purchase a new car, and 1 means that they did. Now, we went through the data, we looked at preliminarily, and what we found was that, in this case, what was it? Here. About 23% of the people did not, or the households did not purchase a new car, or excuse me, 23% purchased a new car, 77% did not purchase a new car. So we have that as our baseline. Now what we're going to try to do is see if we can better those predictions. So in this case, what we were always going to predict if we had no information was that a person did not purchase a car. Okay? Because the probability of not purchasing a car was above 50%. That was what we were going to predict. And we'd be right about 77% of the time. Can we improve that? So to run a logistic regression in SPSS, very straightforward. All we have to do is do analyze, regression, and binary logistic. So what we're going to do to run a regression in SPSS is do analyze, regression, binary logistic. And what we have up here is we have our variables: income, oldest vehicle, recent child, and new car purchase. What we need to do is tell it what our dependent variable is. Our dependent variable here is new car purchase. So we're just going to move that over to our dependent list. And then what we're going to do is we have 3 independent variables: income, oldest vehicle, and recent child. We'll select each of those. And then we'll move this over to the covariates list. Covariates is just the same exact thing as independent variables here. So I want to do that. And then the last thing that I want to do is I want to click on options. And I want to click on the Holmeser, Limshaw goodness of fit, and the CI for the exponential of v. I can leave that at a 95% confidence interval there. That would be perfectly fine. And then I'm just going to click continue. And then I click OK. It'll take a minute to run. So we get a few basic items here. The first here in the case processing summary is just how many cases we have. In this case, the number of cases that we have is 500. So we're looking at 500 families here. What we got from block 1, or block 0, excuse me, block 0 was a few things. We found out in this case that we have 385 of our 500 cases did not purchase a new car during the year. So in this case, 77% of our households did not purchase a new car. And we have 115 cases where they did purchase a new car. Or in this case, 23% of the households purchased a new car during the year. So we have those basic counts. The other thing that we had here that we've talked about was we had the exponential of B. And what this is this is the odds ratio for purchasing a new car. So the odds ratio is the probability of success to the probability of failure. Okay? To us, success in this case is that you purchase a new car. The probability of failure is that you do not purchase a new car. And so what this is telling us, the 0.299, is the odds ratio, is saying that the likelihood that you purchase a new car is 0.3 times the likelihood that you do not purchase a new car. All the odds ratio is doing is telling us what is the likelihood that you purchase a new car. What are sort of this ratio of the likelihood of purchasing versus not purchasing a new car. So you're 0.3 approximately times less likely to purchase a new car than not purchase a new car. So we have that information there. So this is nice. This gives us kind of this baseline again if we're just making predictions based upon, I don't say dumb luck, but just having one prediction, always making that prediction. Now, block 1 is where we're really interested in our results. And block 1 is actually our results from the logistic regression. So what we'll do is we'll go through, we'll talk about the individual parts of this. And the first step that I said to analyzing a logistic regression was to write out the logistic regression itself. Now, what I'll do is, along with posting this video, on Blackboard, I will scan these notes in. So if you don't see everything, the notes will be scanned in, and I'll just post them in course documents. So you will be able to get a copy of these. So what we can do is we can write out, our first step is to write out the regression equation. Now, in a logistic regression, our regression equation is just the natural log of the odds. So what we're dealing with is we're dealing with these natural log of odds, so log odds here. And the log odds look exactly like what we've been doing before in terms of B naught, our constant, plus B1 times by X1, where X1 is our first independent variable, plus B2 times by X2, where X2 is our second independent variable, plus B3, X3 for our third independent variable. So we were able to get this equation which said the natural log of the odds of purchasing a new car are negative 11.332 plus 0.078 times by your income level in thousands of dollars, plus 0.818 times by the value, or excuse me, the age of your oldest vehicle, plus 2.014 times by whether or not you were expecting a child or had a child during the last calendar year. So, and where I got these figures, where I got the negative 11, the 0.078, 0.818, 2.014, I'll put this back up in just a minute. is I got them from right here in the variables in the equation. All I'm doing is I'm looking here at this B column. Okay. My B column in this case represents my code.